Okay, so let's just jump right straight into this, finding the function that passes through the point 27,6 and 125, 10. And let's make sure that we add that this needs to be a power function and not, say, a linear function, which would also pass through these 2 points. Finally, we'll prove that this function is also odd. From the first point, we get this. f of 27 is equal to 6, which is equal to a times 27 to the p power. Now we still need to figure out what a and p are. So let's figure out what our second point tells us. This point tells us that f of 125 is equal to 10, which is equal to a times 125 to the p power. Now, how can I solve this system of equations? Well, I could use substitution, but in this case, that might get a little bit complicated. So let's use another strategy, elimination by division. So I have these 2 equations. 6 is equal to a times 27 to the p power, and 10 is equal to a times 125 to the p power. What I can do is divide the first equation by the second equation, and that gives us a simplified equation that will hopefully cancel some things out. So for instance, 6 divided by 10 is just 6 over 10. A times 27 to the p power over a times 125 to the p power gives us this, where now I can cancel out those a values because they're factors in both the numerator and the denominator. This eliminates one of my variables, a. Now, because p is a common exponent between the numerator and the denominator in this fraction, I can put p outside the whole fraction. So now I have 27 over 125 to the p power. Now, the strategy here is to get either side of this equation into the same base. So I'm gonna reduce the left-hand side of this equation. Instead of 6 over 10, I'm gonna write that as 3 over 5. And so hopefully now we can get the other side of the equation into a base of 3 over 5. Now, if I think about this a little bit, 27 is actually 3 to the 3rd power. And fortunately, the denominator, 125, is 5 to the 3rd power. Now again, that power 3 is common between both the numerator and the denominator, which means I can pull it outside of the whole fraction. So now I have 3 over 5 to the 3rd power, everything raised to the p power. By properties of exponents, I can combine the 3 and the p multiplicatively to give me 3 over 5 to the 3p power. Now we can see that both sides of this equation have the same base, 3 over 5. Now I'm going to write the other side of this equation as 3 over 5 to the 1 power, just for clarity's sake. And so you can see, because the bases are equal, I can set the exponents equal to each other. The exponents must be equal if both sides of the equation are also going to be equal. So 1 is equal to 3p. That means, dividing by 3, that p is equal to 1/3. Now that I have this value of p, 1/3, I can plug it into either one of those original equations. Let's use the equation for the point 27,6. So 6 is equal to a times 27 to the 1/3 power. Remember that 27 to the 1/3 power is just 3, so 6 is equal to 3a. Dividing by 3, I get a is equal to 2. So now I can write my function. F of x is equal to 2 times x to the 1/3 power. All right, so now let's prove that this function is odd. How do I do that? Well, remember from a couple of episodes ago that the function is odd if it follows this relationship. F of negative x is equal to negative f of x. So whenever we want to prove an even or odd symmetry, what we do is we plug negative x into the function and see what happens. If we get negative the original function out on the other side, then we'll know it's odd. So let's plug in negative x into f of x is equal to 2 times x to the 1/3 power. So f of negative x is equal to 2 times negative x to the 1/3 power. Now, we can split negative x to the 1/3 power into 2 separate factors. So negative 1 to the 1/3 power and x to the 1/3 power. Now, negative 1 to the 1/3 power is negative 1, because if I multiply negative 1 times negative 1 times negative 1, I get negative 1 again. So the cube root, in other words, of negative 1 is negative 1. That negative sign can just jump out in front of the whole thing, so I get negative 2 times x to the 1/3 power. But remember that 2 times x to the 1/3 power is just our initial function, f of x. So I can replace f of x with 2 times x to the 1/3 power. This means that f of negative x is equal to negative f of x, and therefore the function is odd. If you have any questions, leave them in the comments below, along with any suggestions you might have for future episodes of How'd You Get That. Hit that like button, subscribe, and hit that notification bell so you never miss another math, physics, or problem-solving tutorial. Thanks so much for watching, and I'll see you in the next problem.